All right, hello once again. This is Jeff Scott of Rankin Technical College. I've been going over the online PDF textbook, AppInventor2, Create Your Own Android Apps. I've gone through the first 13 chapters, which is part 1 of the book, which are the AI2 tutorials, and now I'm jumping into part 2 of the book, which is referred to as the Inventor's Manual. We're first going to go over chapter 14, and as you can see right here, it's entitled Understanding in Apps Architecture. So, this chapter examines the structure of an app from a programmer's perspective. Much of the work that we've done thus far has been imagining it from the user's perspective. So, as mentioned here, one way to describe an app's internals is to break it into parts: its components and its behaviors. The components are basically what are typically referred to as the interface. It's what the end user, the person running the app, sees. All right. The behaviors are what are typically referred to as the implementation. It's the code. All right. So you know that we use the component designer to specify, as it says here, the objects or components of the app, and the blocks editor to add the behaviors. They show this pictorially. It's on the next page here, on page 240 it looks like. Now I'm running from a different book. I've got the hard copy, so that's what goofs me up once in a while, because in the hard copy of the book, this is the bottom of page 216. All right. So you've got the app, and you can see that it's broken down into components, which are made up of our visible and our non-visible components. Our visible, and we've used these. We've used buttons, text boxes, labels, image sprites. We've used other things also. And then you've got your non-visible components. And again, these aren't all of them, but we've used all of these. Those are the ones that don't show directly on the screen. And we have our event handlers. We have our events. The one we've used most often has been the buttons click event, and response, which were our list of function calls. So, as they mention right here under the components, again, there's the visible and the non-visible. The visible you see, the non-visible you don't see. Technically, they're not a part of the user interface, as it says here. Rather, they provide access to built-in functionality of the device. Both visible and non-visible components are defined by a set of properties. Properties they define here as being memory slots for storing information about the components. Well, you've seen this when we've gone over here, for example, and we've gone over to our designer, and I could just pick any of these. If I pick the button here, you can see how the associated properties are shown. That's these. If I click a text box, all right, they're pretty much the same. But if I click a non-visible component like TinyWebDB, you notice how it changes immensely here and here. All right. So the behaviors, again, an app's behavior can be difficult, can be complex. Why? Because it defines on how about the way the app is supposed to respond to any kind of an event, be it a user-initiated event like a button click, or some kind of an external event, such as we saw with the text programs where a text arrives to your phone. And the author mentions here, you may or may not agree, but to me, anyone can learn to build an interface. But, as mentioned right here, it's the difficulty in specifying the interactive behavior that goes along with that interface that makes programming challenging. Now, what you've noticed in here is the fact that this language, it is writing programming code for you behind the scenes, under the hood, however you want to explain it. All right, but the key thing is it is doing it for you, and you are just like puzzle pieces, just putting the pieces together. So you can look at an app as a recipe, but the one thing about a recipe is technically when you create a recipe and you've got 10 steps and you do all of them, and it always comes out the same. But really, an app isn't like that. An app is more a set of event handlers. And what I mean by that is, for instance, in the example we just looked at here, we have no idea whether the person, when they're actually running this app, is going to put in a keyword, or they're going to put in an ISBN, or they're going to attempt to scan. So it's not so much like a recipe, but rather the app is a set of event handlers that are waiting to respond. And most modern software is like that. It is event driven. It's reacting to common events initiated by typically the end user, but not necessarily. Modern apps, as they mentioned right there, are better conceptualized, you can see this right here, as event response machines. Again, that's the way the author puts it. You may or may not agree with the author's terminology here. All right, as mentioned there, as events occur, the app reacts by calling a sequence of functions, one or more functions. We typically call them methods. All right? And those are what you can do, how you can react to some kind of an event, be it a user-initiated event like a button click, or a system-initiated event like handling a text. You call or you invoke a function to make this stuff happen. Again, not all events are initiated by the end user. They give examples: GPS satellites, other phones, etc. The system clock, sensors. And they mention too here on the bottom of the page here. It says, one reason why App Inventor programming is so intuitive is that it's based directly on the event response paradigm. I teach many other programming languages. This is probably the most intuitive language I've come across. Now, as far as some of the event types, as it says, most of these fall into one of these 5 different categories here that are explained on the next couple pages. You've got user-initiated events, the most common. Again, things like you clicking a button. You've got initialization events. And you've already seen where we put stuff into the screen1.initialize event. Because why? Sometimes your app has to perform certain functions immediately when you start up, loading sound files, for example. All right, event handling languages like AppInventor consider the app's launch to be an event. That's why, again, we can put code into the screen1.initialize event. All right, we've also looked at in here, we've looked at things like timer events. As mentioned here, some activities in an app are triggered by the passage of time. Animation is a good example, but there's other things. You might have a game where you've only got a certain amount of time to get to a certain place or whatever. The animation events themselves. All right, remember that when you're working with animation events, if I go back here and look, if I go down here to drawing and animation, we only have 3 events. We've got the canvas, and you need to have a canvas if you're going to use either an image sprite or a ball. You can have a canvas within a canvas. We saw that for that Ladybug Chase app that we did. All right. Also, you've got external events. Again, we talked a little bit about these. You've all done this probably at one time or other. I know the other day I was out and I was looking, I wanted to see a movie, and it said that the system wanted to be able to track where I was. Well, sometimes that makes sense. If I want to find a restaurant in an area and I'm asked, what area I'm in, if the phone can track that, I might say yes because I want a restaurant close to the area in which I currently am. So every app you create is a set of one or more of these event handlers. That's what it's all about. Event handlers can ask questions. In other words, you can query the data, and we've seen this. We've queried the data when we've asked, in fact, in the last example. All right, when we ran this and we put in dogs, we were querying data to get data back. Not only can event handlers ask questions, they can do other things, such as they can repeat blocks. And you've seen this. We did the for each. We did, a do loop, except there's different kinds of loops that you can use. Why? Because oftentimes an event handler will want to execute a block more than once. So what you've seen is we've defined data into variables, and a variable is basically a named memory location whose value may vary while the program runs. Variables store data temporarily while the app's running. If you want the data to persist after the app stops running, all right, if that's the case, then you need persistent data. You either need to save things to a file, or as we've done on several occasions in here, save things to an actual database. You've seen how event handlers can interact with the web. All right? And in particular, we've done one or more things when we've come in here, and where is it? We've used a web viewer. Twitter is an example they mentioned on the bottom of the page here, all right, or the top of this page. As it says, is an example of a web service in which an app inventor can talk. Mashups, if you've never heard those, and we'll talk about them more in chapter 24, mashups are kind of cool. Typically with a mashup, you combine more than one web service together. So what you might have is if you are looking for an airline flight. Let's say I want to go to, San Antonio, Texas, and I bring that up. There might be a mashup in there that shows me hotels in the San Antonio area that are near the airport, rent-a-cars that are in there, that kind of thing. So, as mentioned here in the summary, as an app creator must view the app both from the end user perspective and from the perspective of the programmer. With App Inventor, you design how an app looks. Again, that's its GUI, or its user interface, it's its interface, and you design the behavior. That's its implementation. That's the set of event handlers that you use to make your app behave the way you want it to work. You build the event handlers by assembling and configuring blocks, all right? And there's several kinds, and we've looked at some of those in here. That's pretty much it. I may have less lectures in here, but next I'm going to go into engineering and debugging an app. So I will be back with chapter 15 shortly.